Okay. Okay, guys. So I was here, right? And هلا we were gonna put the acceleration of G, right? Or basically MAG. We're gonna put MAG1 and MAG2. Can someone tell me how does MAG1 look like? And
perpendicular to the bar.
perpendicular to the bar. But why? You know, you can get the acceleration of point G1 based on acceleration of point O, okay? This is my point O, right? So I can say actually AG1 is equal to alpha cross RG1 with respect to O minus omega squared RG1 with respect to O, right? So I'm going to have M, right? M alpha multiplied by L over 2, right? You guys agree? So the first component of that is going to be M alpha L over 2. And then how about what else? Is that going to have more components or that's it?
AM.
G2 كمان.
Exactly, there is. So don't forget that, right? So this actually will actually contribute also to AY and AX. This is a force as well, right? So what is the value for this? It's going to be M omega squared, right? Multiplied by L over
times
2,
R.
which is L over 2 in this case, right?
دكتور ما
Yes.
فهمت هودي كيف حطيتهم هلا.
This one?
يعني الفري بادي دايجرام اللي على اليمين ما فهمته.
اللي على اليمين. Okay, so اللي على اليمين basically, first of all, you have to identify the center of gravities, right? We have G1 and then we have G2, right?
Yes.
Or you can find the center of gravity for this whole system and then find its acceleration. So now when we're taking a shortcut, we can use the center of gravity on each one and then find their accelerations. What is the acceleration of point G1? Remember, every time they ask you to find the acceleration, there are two ways. Obviously, you can use the torques to find the accelerations, but you can also find the accelerations from kinematics. So you can relate the acceleration to alpha, because alpha was given to us. Alpha and omega was given to us. So this is a rigid body, and I'm trying to find the acceleration on point G1. I can use this equation. I know AG1 is going to be equal to acceleration of point O, which is 0 in this case, plus alpha cross RG1 with respect to O, minus omega squared RG1 with respect to O. So point G1 will have a tangential acceleration, which is equal to M alpha R, where R is equal to L over 2, and it will have a normal acceleration, which is M omega squared times R, where R is equal to L over 2. So I have these two components, and then the first component is here, and the second component is here. And I just drew them directly on the figure because I can actually draw them on a figure based on, we know tangential will be perpendicular to this radius, and then omega squared L over 2 is going to be toward the radius.
بس how did I know إنه بدها تكون لفوق مثلا الأوميجا سكوير L over 2? Why isn't it downwards?
Why isn't it downward? Because we said the normal acceleration will always point toward the center of rotation, right?
إن شاء الله يكونوا أسمك من اللي عندنا بالمنظر
مظبوط
يكونوا
مظبوط.
أسمك.
Right?
Yeah, okay.
Okay, omega squared over m omega squared L over 2 is a normal acceleration, and that always points toward the center of rotation, right? And you can prove that by looking at this kinematics equation. I know AG1 is equal to alpha cross R minus omega squared RG1 with respect to O. So this actually has to always be pointing toward that. And I know the acceleration of point O is 0, therefore it is actually pointing toward, I can decompose this acceleration into two components, which are this and that. How about the acceleration of G2 or MAG2?
M alpha L plus the radius.
M alpha L, exactly, plus the radius. Exactly, you don't want to forget the radius here. Exactly, right? The radius from this point up to that. And then how about on this end? I'm going to also have, this guy is going to be my M omega
square L plus radius.
L plus the radius, exactly, right? Okay, guys, so am I missing anything or that's it?
Moment, IG alpha.
Exactly, we're missing the moment. So here, those two rigid bodies will have the same alpha. So I can directly add them up, IG1 plus IG2, right? Multiplied by alpha, and then that is a moment, right? And then that moment is basically following the direction that I have for alpha. Okay, what are the knowns? What are the unknowns in this problem? Here, if they gave you alpha and then omega, it means you know all the accelerations, right? You guys agree? If they gave you alpha and then omega, it means I know this acceleration, I know this guy, I know all these, right? And then here, I'm going to be able to, so if I sum the forces in the x direction, I'm going to be able to solve for ax, right? If I sum the forces in the y direction, I'm going to be able to solve for ay. And if I actually sum for the torques, I'm gonna be able to actually solve for how much torque is needed to actually have these accelerations. And here I wanna actually tell you guys one thing which is kind of beyond what we're learning in this course. There's something which is called forward dynamics and then inverse dynamics, right? Forward dynamics is when you actually know the torque and then you solve for alpha. Inverse dynamics is what we are actually doing in our course. Inverse dynamics is, we know alpha, etc. here, and then we're solving what are the reactions that are giving you these. Overall, forward and then inverse, right, are related. Why? Because ultimately you are going to have a number of knowns and a number of unknowns that you can actually use to solve your problem. But again, in this problem, we know alpha, we know omega, we can solve, we know the accelerations, we can solve AX, AY, and torque. So let's let us begin by
المومنت تبع هيدي كلها بناخد IG1 plus IG2 times alpha.
yes.
Okay. Yeah.
You just add them up. Okay, how can I find AX in this case? Just sum the forces, right? And
دكتور بس سؤال.
Yeah.
هيدا منه ديسك هاز سفير كيف بنعمل للاي جي؟
Okay, if it was a sphere, there is a table basically. I'm not gonna ask you guys to get the IG, but IG for a sphere, I believe, is 4/5 mr cube. There's a table for
لا ما عندنا التيبل نحن
yeah, on the exam I will give you like if it's a disk or a cylinder or if it was a sphere, I would have to give you the moment of inertia. All right. Okay, how do I get AX? I'm gonna have to what? Sum the forces, right, in the next direction. And if I sum the forces in the next direction, what am I gonna get? So on the left figure, I'm gonna have AX, right? Do I have any more?
AX.
That's it, right?
No.
How about on the right figure? Well, let's say this angle here is theta, right? Then what is this angle right there? Theta, okay? How about this angle? Theta, right? And then that one here. Theta. And then this guy will be theta. Okay, can someone tell me what is AX right now on the pen?
تطلع M alpha L over 2 cosine theta.
Exactly, M alpha L cosine theta.
Minus M omega square L over 2 cosine theta كمان.
لا هيدي sin theta.
لا sin theta.
And then how about on the bottom? Similarly, right?
Plus omega L plus R هي ذاتها بس بنغير بس
L plus R cosine theta minus M omega square L plus R sin theta. And that's it, right? If I want to get the force on the y direction, I'm going to end up with what? AY minus, so the two weights, right? Which are going to be what? So M plus big M, okay? G, right? So AY minus MG minus big MG, so minus MG minus big MG. And then here I'm going to take the vertical components of these inertial accelerations. And here I'm going to end up with what? So taking on the first one, I'm going to have M alpha L over 2 multiplied by sine theta plus M omega squared L over 2 cosine theta, and then this guy, which is equal to M alpha L plus R sine theta, and then the centrifugal omega squared L plus R cosine theta, and then there you go, right? So the vertical component, obviously, the vertical component will increase, obviously, if the weight increases. So if you put these guys over here, then they would be plus, right? So I can actually do this equal, and then this guy's gonna be plus, right? So I just moved M plus M to the other side. If I increase one of the masses, AY will increase, which makes sense. What happens if the centrifugal acceleration or the velocity increase is as expected, right? If the velocity increase, AY is gonna increase, right? If you increase the angular velocity of the swinging, right, then AY is gonna increase, right? You're gonna have to have more AY, right? Again, if alpha increases, you're gonna have more AY. So AY will increase if you have more velocity. on it, or more angular velocity. How about the torque, right? I can actually solve for the torque. How can I solve for the torque? You sum the torques about point O, right? And then you can use any direction, right? And if I use my counterclockwise direction, then what do I have in terms of moment? I'm going to have the torque, which I'm applying, minus the first one, right? Minus mg L over 2 sine theta
في
minus.
عامل about any point.
عم بحكي
I'm sorry?
بالظبط.
في أعمل المومنت about any point مش بس O معاك.
Yes, exactly. About any point, and then the results will always be correct. You can sum it about this point if you want, right? Or this point. It doesn't really matter. So here we're
بس
choosing
أحسن
this
شيء
point.
محل ما في forces كانوا يصيروا زيرو محل ما في أكثر شيء forces.
Exactly. So we can use these because you want to cancel the moment arm for AX and then AY. Right? If I sum the moments about that point, the moment arm for AX is going to be 0, and then the moment arm of AY is going to be 0. Again, guys, when you're summing the moments, remember, you're not summing about a point, right? About an axis. And this axis is going through the page about that point. Okay, so here I'm summing the moments about that point because I can get rid of AX and then AY. So here, the torque is going to be equal minus MGL over sine theta minus large MGL sine theta. On the right side, what do I have? Can someone tell me what is the moment arm that I'm going to have here? Okay, let us begin by what is the moment arm for m omega square L over 2?
0.
0, exactly. So here I only have
0.
tangential components, right? And so I only have m alpha L over 2 and the other one, right? So these are equal to m alpha L over 2 multiplied by how much? By L over 2, right? Which is the moment arm for that force. How about the other one? It's going to be m alpha, right? L plus R. And by the way, guys, we used capital letter for the mass. So, that is, whatever we have L plus R. I think you guys got it very quickly. So that is very basic here, right? So we have, this is a capital L. So for the other one, I'm going to have, okay, let me rewrite that. So I have, so this is omega. Okay, so on the right side, not omega, right? We have omega square will create no moment, right? Because it's pointing toward us. So I only have to take m alpha L over 2. So I have small m alpha L over 2 multiplied by L over 2. And then the other one I have large m, right? Alpha L plus R multiplied by L plus R. And then what else do I have?
Minus IG1 plus IG2 alpha.
Is it minus or positive?
No, plus.
Plus.
Positive. So positive, right? So plus IG1 plus IG2 alpha. And then you notice that all these are actually multiplying alpha. And you also notice that the units for these are actually also as IG, right? So this will end up being ML square over 2, right? So M L over 2 square plus large M L plus R square plus IG1 plus IG2 is multiplying alpha, right? So here, the torque equation, if you know the torque, you can get alpha, and then if you know alpha, you can get the torque, right? This is what I mean by, like, forward, you have the forces, you can solve alpha. Inverse, you have alpha, you wanna solve what is the torque that you need to apply, because ultimately, guys, what comes after dynamics is control, right? So you learn dynamics so you can model the system, and then ultimately, actually, when there is a course basically that you'll take later was instrumentation course was Dr. Aqli, basically where you learn control. So let's say you actually have you can actually apply a torque to control theta, right? So you can basically, you have a motor, for example, that is moving this, and you would like to actually make this pendulum stay at 30 degree, or you were at 20 degree, you want to go to 30 degree. Understanding this dynamics, what is actually happening as a result of the torque, what is the angular acceleration. Later on, you can use these to actually develop a controller to allow you to control the motion, for example, of the pendulum, right? But this is ultimately the dynamics of that system. And let me actually rewrite it one more time. So here, what do I have? So I have M. Let's try to factor this out. So I'm going to have M over 2 plus big M multiplied by GL sine theta plus these guys, right? Plus IG1 plus IG2 multiplied by alpha. Okay, so okay, guys, any questions about this problem? How you're doing that, right? How you are decomposing this into two masses, right? Instead of having us, to try to find where the center of gravity is, we can directly just put these where they are. Don't forget to put IG1 moment of inertia about the center of gravity. We have three unknowns, AX, AY, and the torque. We can sum the forces in the X, sum the forces in the Y, summing the torques. We can solve for AX, AY, and then torque from the three equations that we have. Okay, guys, so I'm going to actually solve we'll actually, guys, have another session on Monday, and in that session we will actually solve more problems. But I think let me actually stop here today, and I'll answer any questions that you guys have. Otherwise, you can work on these over the weekend. And why don't you guys solve example 11? Okay, let me show you what I would like you guys to solve as well for Monday. And so solve example 11. I've solved a very similar problem to it, and solve example 11 and then 12. And we'll also solve them as well together. Problem 12 is an interesting problem, so solve it. And on Monday, what I would like to do is I'm gonna do a recorded lecture again, problem solving problems. And if you guys have questions, we can address them. If not, then we should be fine. And I'll also have, so we're going to solve them at 10, and then at 11, I'll actually have office hours in case some of you actually have more questions or would like to have specific questions in assignments. Any more questions, guys, or are we good?
Doctor, I have a question concerning the last
Doctor, I have
example
a
in the last lecture, similar to example 1.
I'm sorry, which one, Ivana, did you say?
Yes, I was just asking that the last example in the last lecture, it's similar to example 1. You drew it.
The last example in
chapter 17, part 4, the last example.
Okay, so the last example is similar to which one?
It doesn't have a number. You drew it and you told us it's similar to example 11, I guess, but it's
هيدا
without
تبع بيكون في
rolling.
بار محطوط
Yes, exactly. But here, yes, exactly. Here, P is at the bottom, and then you have this. You have a wheel, basically. You don't have the coefficients of friction. But this is very simple, guys, right? Just you draw the free body diagram. You have the force. You have the acceleration of the center of gravity in the middle. Right? This is very important. What most people make mistakes in is they don't realize that you have one force. Okay, that's it. You actually have MAG has to be here, right? At the middle, some people would put MAG where the force is applied, right? So remember, yes, yeah, go ahead.
I was just asking when we assume that it's not slipping. When we assume it's not slipping, and you are considering, can you hear me?
Yeah, I can hear you.
When we are assuming that there is no slip, we assume it's rotating about O. That's why we can no, and it's not tipping. It's just rotating.
Exactly. Yes.
If it's not slipping.
If it's not slipping, then it is rotating about the pivot at the ground. Right, and there you can say AG is equal to alpha R, right? Where R is a distance from the point.
دكتور أنا ما كثير فهمت السؤال، تقدر تفسرها هلا وتفسرنا هو بالمنطق؟
Yeah, sure. I think, okay, what she's asking is the following, right? In the last in the last example, in the last lecture that I recorded, we had a problem that
Yes,
looked like
the
that,
distance
right?
problem. That's
We had the problem that looked like that, okay? And we had the force applied, I assume basically on the middle. All right, and I tell you that the coefficient of friction here, you have mu k, and then you have mu s, right? And the mass of the bar is m, and the length of it is l, and then g acts downward. I would like to find the acceleration of point P, right? She was asking so how, she was asking if we assume that this guy is not slipping, right? Then can we assume that this is mainly rotating? And the answer is yes, right? If this guy is not slipping, then, it is actually pivoted about this point and it's actually rotating like that. And I've actually solved the problem last time, but I can quickly solve it here. As a result of that force, we know the friction will oppose the motion. So this is your friction, right? And how do you solve from here? So you're gonna draw an acceleration diagram. So I'm gonna
Doctor, I can't see the
دكتور بس
screen.
I can't see.
Oh, you can see right now?
صورة معلقة.
مش شايفين شيء نحن.
Okay, how about now? Is it getting better or no?
You can only see your paper والماوس تبعك.
الصورة froze.
Okay, how about now?
Yes, I can see now.
Okay,
Yeah.
so here basically, how do you solve this problem? So how you want to put the friction, right? And we're going to put the friction as F. We don't know the value of F. You never want to put F is equal to mu S times N here, right? Mu S times N is the maximum friction at the verge of slipping. Here, the value for the friction is F. But we're going to assume that thing is not slipping, right? It's not slipping, meaning that point is pivoted. So if you're applying a force, this guy's going to mainly like rotate like that, right? And here, basically, we know we want to put MAG is going to look like that, right? This is our MAG. And then what else do we have? We have IG alpha.
دكتور الصورة مش واضحة عند ال F to the left أو to the right.
F is going to be to the right.
What's
F
the
تبع
friction?
الفريكشن.
I'm sorry?
تبع الفريكشن مش الفورس.
Oh, the friction is going to be to the left, right? This is the arrow, right? It's pointing to the left, right? Opposite to the force.
Okay.
Okay. So how do you solve this problem? So we can sum the forces in X direction. And if you sum the forces, we're going to end up with what? Like the force minus the friction, right? It's going to be equal to how much? M AG. All right. Now what else? So I can obviously sum the forces in the vertical direction, right? But we don't need them. Let me just kind of quickly do that, right? We can sum the forces in the vertical direction, but we don't need them because it will just give me N is equal to mg. But let's just kind of just put it there. So you have N minus mg is equal to 0 because we have no acceleration in the vertical direction. So what is the third equation that I'm going to use? So the third equation, I'm going to sum the torques about this point O, right? And what is that? So I'm going to have F multiplied by L over 2. It's going to be equal to how much? It's going to be equal to
MAG L over 2.
MAG over L over 2 plus what? Plus IG alpha.
IG alpha.
Okay. So here, how many equations do we have and how many unknowns? So the unknowns that we have are F.
The equations for unknowns.
We have, so the unknowns are F, right? AG alpha. And how many? I'm sorry.
ما في N كمان.
And then you can say N, exactly, if you're gonna count N, that's fine. So how many unknowns do I have? I have F, AG, alpha, and then N. How many equations do I have? I have 3 equations. So I'm not able to solve all of them, right? Or I may not be able to solve any, I may only be able to basically solve for N because on this equation, that equation is one equation, one unknown, so I can solve N is equal to mg. But this equation, this guy and then that guy, 2 equations, they contain 3 unknowns, which are F, AG, and alpha. So what do I have to do here? Here I have to make some assumptions. So I'm going to assume that this guy is essentially rotating. It's not slipping. So we assume the bar isn't slipping at O. If the bar is not slipping at O, then I can basically write a new equation. Can someone tell me what it is?
G equals alpha L over 2.
equal alpha.
Alpha times L over 2. Okay. And do you guys know where that equation is coming from?
If we relate to point O.
Yes.
From kinematics, right?
Well,
AG is equal to alpha, right? Cross RG respect to O minus omega squared, etc. Right? And then if you take only the I components of those, you're going to actually write that. So how many equations do I have? I have 1, 2, 3 equations and 3 unknowns, right? Or you can count them 4 equations, 4 unknowns, including N. So here, this actually will enable me. So this will go directly here, right? And then from here, I can actually get alpha, right? So this is equation number 3. So I can هلا هون 3 will give me what? F multiplied by L over 2. So AG is equal to alpha L over 2. So I'm gonna end up with M L over 2 squared multiplied by alpha. So this whole thing multiplied by is factoring out alpha. And then here I'm gonna be able to get alpha. So alpha is gonna be equal to F times L over 2 divided by M L2 over square plus RG. So we actually got that. All right, so now you have alpha. You can get what? You can get AG, right? AG is going to be equal to alpha R, right? And once you have AG, you can actually get the friction force. We can solve for the friction force. What is the value for the friction force? Friction is going to be equal to F minus MAG, right? MAG, which is equal to alpha R, or F L over 2 square divided by ML over 2 square plus IG. Do you guys understood how I got the value for the friction? I basically resolved that problem. So I know the pushing force minus my friction has to be equal to whatever I have remaining for the acceleration at the center of gravity. So F is going to be equal to F minus MAG. And I know AG is related to alpha simply by multiplying alpha by L over 2. So I'm going to F minus MAG, which is M alpha times L over 2. So L over 2, I'm going to basically put a square on that. So I got the friction force. Does it make sense, guys, how we got here?
Yes, and now we compare F to mu at N.
Exactly. Now you want to compare F if it's larger than mu S times N. It means what? It means my assumption, this assumption is incorrect. If F is greater than
F equals to mu K.
exactly, then it means if F is greater, it means that F is actually equal to mu K times mg. So here, basically, I'm getting my force equation from this equation and not from here, right? So now the friction is going to be mu K times mg. Now I'm going to be able to actually get AG directly, right?
Doctor,
Okay.
I have a question.
So here,
إذا
let me just finish that up very. So I'm going to have F minus mu K mg is equal to MAG. So here you are solving AG directly. Can someone tell me how can I get alpha here? From here, right? From the third
AG
equation.
equal alpha L over 2.
From here. From the third equation, now I have AG, which is here. I can basically solve for IG alpha, for alpha, right? So F L over 2 is equal to MAG L over 2 plus IG alpha. So alpha is going to be equal to F L over 2 minus MAG L over 2, and then this whole thing is divided by IG. And I know what AG is. So alpha is equal to F L over 2 minus, so MAG, so M and M will cancel out, so minus F minus mu K mg multiplied by L over 2, and then this whole thing is divided by IG. So here you have F and F will actually cancel out, so you're going to end up mu K mg L over 2 divided by IG. So this is the value for alpha. And then you can see basically if mu K increases, what happens to your angular acceleration? Will increase. will increase, which makes sense, right? Here, basically, we're assuming free friction on it, right? And the other thing here, we know alpha will always be positive, right? So if you're applying a force, it's impossible, but basically to tip it on the right? That is why alpha is actually positive. Okay, guys. So this is a standard problem that you have to be very familiar in how you're solving that. And any more questions, guys, on these problems?
Doctor,
That's the
question
problem.
problem.
Okay, Amana, let me open. So Alessandro can go.
كان في problem بالhomework شوي غريب يعني سألونا is it going to tip or slip فيك ترجع تفسر شوي؟
Yeah, sure. So if it is going to tip or slip, tipping basically means, so in this problem, tipping is what we solved earlier, right? And then tipping is gonna slipping is gonna occur. It's like how do you guys tell if it's gonna tip or slip based on what we just did?
Based on the friction.
It will slip إذا F is greater than US dot N و it will tip إذا شيء خاصه بالنورمال إذا ماني غلطان.
Kind of, right? So it will
هون
tip.
it will
يبطل
tip.
في contact إنه وقت النورمال يزيح عن النص.
Right. So we're not going to be solving it for, when basically this guy is slipping and it's in a weird configuration. Why? Because when this guy basically is in that configuration, basically now mg will actually give you some moment arm, right? And then we didn't include that. What they basically mean is that if it's going to tip, if it will tip if f is less than us times n, and then it will slip if f is greater, right? This here, it will tell you whether tipping will occur or slipping will occur, right? So based on the friction value,
بس هون with slipping it will tip يعني بالذات هيك.
Whether slipping or tipping.
Okay, so the question here is very big, right? So it will slip if f is greater, and it will tip if f is less than us times n, right? If f is less than us times n, then this point will not move. Then this guy will tip, and that is.
Why would it tip if F is less?
And obviously, yes. So obviously, guys, when it slips, it will also tip, right? Why? Because you actually have an angular acceleration, right? So we have this alpha, and then it will basically be kind of, sliding and then also tipping at the same time. Why it will be sliding? Because you have some acceleration at the center of gravity, and you basically have a alpha, right? So you can basically find the acceleration of that point, and then you would see that this point will actually have some acceleration.
هن دكتور بالبروبلم عملوا شيء شوي غير يعني عملوا زادوا unknown x وهال x إذا مثل ما قلت قبل إذا صارت النورمال على بوينت واحدة وإذا الإكس ثقبت معها يعني في tipping.
Oh, okay. So maybe right, but
شيء غريب شوي.
Okay, maybe you are talking about the problem where basically you have more distance, right? Or how about so we solved a problem like that earlier, basically when this whole block basically tips. When we had basically if you remember, we had the force applied, right? And then we said when will that guy tip or slip? If the problem was similar to that, we've already solved that problem. When this guy is tipping, basically the normal will actually move here, and then you sum the moments about that point. You are going to have mg here, and then on the right figure, you are going to have, this is your acceleration, right? And we looked on that, and then we said slipping will occur if the friction, right, is greater than us times n. So we've already solved that problem. What can you tell me that problem? What problem you're asking for, and then maybe we can also solve it on Monday during our problem solving session.
هو من الهومورك مثلها بس الكريت inclined.
Okay, why don't you send me that problem by email after we are done,
لا.
and then
هدول اللي انت حطيتهم دكتور. انت مش تحط لنا homeworks؟
Yes. Yeah, I'm thinking like if you can tell me which problem number.
اوكي دقيقة.
Okay, I think you mean the problem 1742, right? And let me actually share that. Okay, so I think this is what you are asking, right?
ايه هيدا ال 1740.
Okay, so here basically we have a crate that has a mass 50 kilogram and rests on a cart having an inclined surface. Determine the smallest acceleration that will cause the crazier to tip or slip relative to the cart. What is the magnitude of this acceleration? Okay, so guys, we have solved a very similar problem where this guy is parallel, right? And here basically you would have to look at the distance basically. You're basically going to consider a point here at the bottom, and basically we're going to assume that this will tip if summation of the moment about this point is a normal force basically is going to come all the way here, and it will basically have no moment arm with respect to a point here. And how about we actually solve that problem as well on Monday during our problem session? But at this point basically I'm kind of running out of time. Yes.
بس شيء صغير هن كمان حطوا يعني assume that the crate slips و F هي mu S N بس نحن كنا قايلين انه اذا it slips هي mu K N. لا
As if it slips, so so at the verge of slipping, what we are testing for in the problem that we just solved is we solved for the value for F. Okay, if F is greater than mu S times N, it means that it is slipping. But if I tell you, what is the force at the verge of slipping when it is just about to slip, in that case, you want to make the friction is equal to mu S times N. Here, basically, you are putting the maximum value for the friction to solve for when the system is about on the verge of slipping. That is why here they are saying Fs equal to mu S times N, right? And why don't you guys kind of spend some time to also think about it, and then on Monday I'll actually solve that problem. And if you guys have some other questions that you would like me to solve as well, then do email me, and then we can also solve all of them on Monday during our session at 10 a.m. Okay, guys. So that is it for today. And again, we'll meet again on Monday to do problem solving. And if you have any specific questions, just email me the number of the problems that you would like me to solve, and then we can solve them. But email me those questions before our session on Monday, so I can take a look.
Are you going to record Monday's session?
Yes, all the sessions are going to be recorded.
Okay.
Okay, guys. Thank you, guys, and good luck.
Thank you, Doctor.
Thank you.
Thank you.